Shipping containers do not fail from an excess of vertical load. They fail from structural torsion. The vast majority of foundation problems arise because builders are attempting to solve the wrong engineering problem. The focus is placed on strength when the actual mechanism of failure is rotation. The common approach is to focus on vertical load capacity. The assumption is that a foundation's primary role is to resist being crushed. This leads to an obsession with material strength, higher PSI concrete, thicker steel reinforcement, and deeper piers. The belief is that a stronger foundation is a safer foundation. This approach reinforces the structure against a failure mode that is almost never the issue. It does not address the actual mechanism that compromises the integrity of a rigid welded steel frame. It is a solution for a problem that does not exist. A shipping container must be understood as a rigid, welded steel chassis, not a flexible building. Its structural integrity depends on all its primary support points remaining in a perfect coplanar relationship. Torsion is introduced when one of these support points moves independently of the others, even by a few millimeters. Consider a four-legged table with one leg that is slightly shorter. The entire tabletop is forced to twist to accommodate that one imperfection. A container behaves in the same way, but it has no capacity to flex. When a single foundation pier settles or heaves differently from its counterparts, it introduces a rotational force into this rigid chassis. The structure is not designed to absorb this rotation. The force does not dissipate. It transfers directly into the welded seams, the door frames, and the window openings. The material science is clear. A standard container is engineered to support the weight of 8 other fully loaded containers stacked on top of it. Its capacity for vertical compressive load is immense. The steel frame excels at channeling weight downwards. The structural weak point is not its ability to handle compression, it is its inability to tolerate differential movement between its supports. The structure can bear the load of tens of thousands of pounds pushing down on it, provided that load is distributed evenly across a stable, unified plane. It cannot, however, forgive the rotational force introduced by one corner moving independently of another. The frame can withstand the weight of a tank, but it cannot tolerate the twist from a wobbly table leg. Containers don't crack because they're weak. They crack because they're twisted. Weight pushes down. Torsion tears sideways. Understanding this changes how one designs everything below the container.